Good day to you all. We are back to solving physics problems, and for today, our main topic is temperature and heat problems. So again, we'll be solving three problems from the University of Physics book, 4th edition of Pearson. So for our first problem, a constant volume gas thermometer registers an absolute pressure corresponding to 325 millimeters of mercury when in contact with water at the triple point. What pressure does it read when in contact with water at the normal boiling point? So this is a thermometer, and for our given, we have a pressure of 325 millimeters. So this is how high the mercury rises when in contact with the water at the triple point. So the temperature of water at the triple point is 273.16 Kelvin. It is a given. And for our boiling point, of course, the boiling point of water is 100 degrees Celsius. Now, we're looking for the pressure of the water when in contact or rather the pressure when it is in contact with water at the normal boiling point. So for our equation, temperature is equal to the temperature at the triple point times the pressure all over the pressure at the triple point. So with just a revision from the formula, we can say that the pressure will then be equal to the pressure times at the triple point multiplied by the temperature of the boiling point all over the temperature at the triple point. So we first need to convert our temperature here in Kelvin because our temperature at the triple point is in Kelvin, and so our boiling point now will be equal to 373.15 Kelvin, because we just need to add 273.15 to the degrees at the Celsius in order to convert it into temperature in Kelvin. So the pressure is now equal to 325 millimeters multiplied by the temperature of the boiling point, which is 373.15 Kelvin, all over 273.16 Kelvin. The pressure will be equal to 443.17 millimeter. So for the second problem, a steel tank is completely filled with 2.90 cubic meter of ethanol when both the tank and the ethanol are at 33 degrees Celsius. When the tank and its contents have cooled to 20 degrees Celsius, what additional volume of ethanol can be put into the tank? For our given, we have a volume of ethanol, which is 2.90 cubic meter, a temperature of 33 degrees Celsius, and the second temperature, which is at 20 degrees Celsius. It is also given that the coefficient of the volume expansion of steel is equal to 3.6 times 10 to the negative 5. For our equations, the change in volume is equal to the coefficient multiplied by the initial volume multiplied by the change in temperature. So in order to solve for this, our change in temperature is equal to the second temperature minus the first one. So just substitute 20 degrees Celsius minus 30 degrees Celsius. It will give us a value of negative 13 degrees Celsius. As for the change in volume of the steel, since now we have the coefficient, so just plot in all our given. So 3.6 times 10 to the negative 5 multiplied by the initial volume of 2.90 cubic meter multiplied by the change in temperature of negative 13 degrees Celsius. It will give us the change in volume of steel of negative 1.4 times 10 to the negative 3 cubic meter. The negative sign indicates that it gets smaller. So now let's solve for the change in volume of the ethanol. So it's just the same formula, but with different coefficient, because now the coefficient for the ethanol is 75 times 10 to the negative 5. So just plot it in all to give us a value of negative 28.2 times 10 to the negative 3 cubic meter. Again, it's with a negative sign, meaning it gets smaller. So now in order to get the volume for the steel, we need to get first the initial volume minus the change in volume. So the given volume here is 2.90 cubic meter. So 2.90 cubic meter minus the change in volume of steel, which we have gotten from the previous one, which is 1.40 times 10 to the negative 3 cubic meter, to give us a value of 2.89 cubic meter. This is now our volume for the steel. As for the volume for the ethanol, it's just the same, but let's just change the volume, the change in volume, to the change in volume in ethanol. So it is now 2.90 cubic meter minus 28.2 times 10 to the negative 3 cubic meter. It will give us a value of 2.87 cubic meter. This is now our volume for ethanol. Now, since we have gotten both the volume for the steel tank and the ethanol, we can now solve for how much volume of ethanol can be put in the tank. So in order to solve for that, we just subtract the volume of the ethanol from the volume of the steel tank. So 2.89 cubic meter minus 2.87 cubic meter will give us a value of 0.02 cubic meter, or when changed to liters, it will give us a value of 20 liters. So this is the amount of volume that ethanol can be still put in the tank. So for our third problem, we have here a 15.9 grams bullet traveling horizontally at 865 meters per second and passes through a tank containing 13.5 kilograms of water and emerges with a speed of 535 meters per second. What is the maximum temperature increase that the water could have as a result of this event? So for our given, we have the mass of a bullet, which is 15.9 grams. The initial velocity, or the first velocity, which is 865 meters per second. The mass of the tank, which is 13.5 kilograms. And the second volume, which is 535 meters per second. We are now looking for the change in temperature, since it is asked here what is the maximum temperature increase. So we have an equation of Q, which is the quantity of heat, equal to the mass times the specific heat times the change in temperature. And we have here the Ke, or the kinetic energy, which is equal to 1/2 mv squared. And I will discuss later why we will need this. For our solution, we can say here that the kinetic energy is equal to the quantity of heat. So why is that? Because the traveling bullet lost a kinetic energy, or the lost kinetic energy of the traveling bullet is equal to the quantity of heat absorbed by the water in the tank. So now let's solve for this. The kinetic energy is equal to 1/2 times the mass of 15.9 kilograms. So I converted this because it's only in grams, so we converted it into kilograms. Multiplied by, so since we have two velocities, so v1 minus v2. So 865 meters per second squared minus 535 meters per second squared will give us a kinetic energy of 3.47 times 10 to the 3 joules. This is the lost energy of the traveling bullet, but also this is the quantity of heat absorbed by the water in the tank, which the bullet passed through. So our change in temperature is equal to Q is equal to Q over mc. We just played with the formula in order to get this. So it is said that the specific heat of water is 4.19 times 10 to the 3 joule per kilogram times Kelvin. So now we have this, so let's substitute our gathered data. So change in temperature is equal to the Q, which we have gotten from before. So 3.47 times 10 to the third power joules all over the mass of 13.5 kilograms, mass of the tank, and our specific heat for water, which is 4.19 times 10 to the third power kilogram per joule Kelvin. We now have the temperature of 6.13 times 10 to the negative 2 degrees Celsius. So this is the maximum temperature increase that the water had as a result of the bullet passing through it. Through the tank, rather. So that's all. Thank you, and if you have any questions, you can find me here at my email. Hope this one helped too, so have a good day.